In this video, we'll estimate square roots, and we're going to use a number line in order to help ourselves. Would you pause the video and draw the number line up to 15 and the square roots, which are the perfect squares of the numbers 1, square root of 1, 1, square root of 4 is 2, square root of 9 is 3. Those are the perfect squares because their answers are whole numbers or integers on the number line. We have that same exact number line on the previous lesson when we discovered how the square and the square root works, and we're going to have the same number line used for estimating. Draw the number line first. Then, to estimate square roots that are not perfect squares, for example, square root of 12. By looking at our number line, square root of 12 is not here. So that means it's not a perfect square. That means if I have 12 units, I can't build a square. So let's say I look at my units and I put them together and I try to put a square, and all I can do is a rectangle. I can build it this way or this way, but I can't create a square. I can create a square using 9 units, that would be 3 by 3. I can create a square using 16 units, that would be 4 by 4. But if I only have 12 units, that is not a square. So I'm going to have to try to cut from these squares and put them over here, so that will complete the square. But that cutting part, it means breaking something, is going to give us a decimal value. So it's not going to be a whole number. And let's see how that works on the number line. So to estimate square roots, we will use the number line to determine the approximate decimal value. A few steps to do that. First, we're going to find the perfect squares above and below your answer. Means, what are the perfect squares closer to the answer, which is square root of 12. So I'm going to look above and below, or what is it in between, which two perfect squares with square root of 12 fall between square root of 9 and square root of 16. So my answer should be between 3 and 4. So find the perfect squares above and below your number. My number is square root of 12 that falls in between square root of 9 and square root of 16. The answer will be a decimal between the integers representing the square root of those two numbers. So the square root of 12 being between 3 and 4 will be a decimal between the integers representing the square root of those two numbers. So the 3 and 4 means a decimal between 3 point something. So the answer will be a decimal between the integers representing square root of these two numbers. Step 3. We are going to estimate the decimal based on how close the number is to each of the whole numbers. In other words, is it closer to 3 or closer to 4? We are going to find a good decimal based on how close your number is to each of those whole numbers. Let's see this example. Estimate square root of 12. How would I do that? Square root of 12 is not a perfect square. The estimate will be not the equal sign, but a wavy sign. Wave means approximate value. Then I'm going to start with the model, going through the steps. Step 1 says find the perfect squares above and below. So in other words, on the number line, what would be the closest perfect squares? What would be the square root of 12 in between? The perfect square 9 and the perfect square 16. The square root of 12 is between square root of 9 and square root of 16. That means that I can build a square using 9 units. That would be the whole number 3. and I can build a square using 16 units, that will be the whole number 4. So on the number line, square root of 12 is between integers 3 and 4. Step 2. The answer will be a decimal between the integers representing the square root of those numbers. So the decimal will be 3 point something. 3 point something. Step 3. Estimate the decimal part based on how close your number is to each of those whole numbers. So between the square root of 9 and square root of 16, there's still square root of 10, square root of 11, square root of 12, square root of 13, square root of 14, and square root of 15. So those are all not perfect squares. They are all irrational numbers or have decimal values. Our number is square root of 12. So out of this 1, 2, 3, 4, 5, 6 integers is the third third number. So that has to be somewhere close to half, maybe 3.4. So that could be an estimate, but let's see that confirmation again on the calculator. So 12 and then square root of 12. 3.4 rounded up to 3.5 or 3.46, so we don't need all that irrational ongoing sequence. We just need the whole number and a good decimal approximation showing that it's closer to 3 and not to 4. So the square root of 12 is going to be closer to 3, which a good approximation could be 3.4. Let's see another example. What if I have to estimate square root of 70? Step 1. What two perfect squares is square root of 70 in between? So if I can't build the square using 70 units, what two squares can I build? Closer to 70 is 64 and 81. So square root of 70 falls right between the perfect square of 64, which is 8 by 8, and 81, which is 9 by 9. So my estimate should be a number between 8 and 9, because I can build a square with the sides of 8 by 8 to get 64. I can build a square 9 by 9, but I can't build a square using 70 units. So 70 whole units. It will be a approximate value. Step 2. The approximate value will be a decimal between integers represented by the square. So between 8 and 9 should be 8 point something. Then we have to look what would be a good decimal. Step 3. Estimate the decimal based on how close your number is to each of the whole numbers. So square root of 70, is it closer to 64 or is it closer to 81? From 64 to 70, we have 65, 66, 67, 68, 69. That would be 6 units to get to 70. But from 70 to 81, it's 11 units. So 6 units this way, 11 units that way. 70 is going to be closer to 8, maybe somewhere over here. So that will be less than a half because it is closer to the 8. We are going to use a decimal value, maybe 8.3, 8.4. Let's see what is the calculator giving us as an answer. 8.3 rounded up to 8.4. So that was a good close guess. I'm going to say 8.3. 8.3. Why not? If you say 8.4, that's still good enough, as long as it's not a 8.9 or 8.7, which is on the other half, which is closer to 9. So example number 3. Let's see an estimate of square root of 5. You can pause the video and try on your own, or go along with me a little bit. Square root of 5 is between what two perfect squares on the number line? So I have square root of 5 over here, which is between square root of 4 and square root of 9. So I can't build a square using 5 units, but I can build a square using 4 units, and I can build a square using 9 units. Square root of 4 will be 2, and square root of 9 will be 3. So my estimate has to be a decimal between 2 and 3, approximately 2 point. What would be the closer integer? So estimate the decimal based on how close the number is to 2 or to 3. So square root of 5 is right after square root of 4. We have 5, 6, 7, 8, and then square root of 9. So really, really close to 2. I'm going to say maybe 2.2. I'm going to check that. So 5 and square root 2.2 is what the calculator says. 2.2, 2.1, 2.3. The range has to be really, really close to the number 2. How about example number 4? Estimate square root of 110. Starting with thinking what two perfect squares is my square root in between. Square root of 110 is not the perfect square, but the closest two are 100, square root of 100 is 10, and 121, square root of 121 is 11. Those are the two integers that square root of 10 is in between. So at some point we can have a question, what two integers is your root in between? Then the answer would be between 10 and 11. Step 2, what would be the decimal approximation? That would be 10 point something. What would be the actual decimal number closer to 10, to 100, or to 121? So that means closer to 10 or to 11. So 110 is 10 units away from 100 and 11 units away from 121. So it should be a little bit past that middle. So I would say 10.5 could be a good estimate. Let's see. 110, 10 point approximately 5 to round it up. That's a good estimate. Close enough. So in order to estimate the square roots that are not perfect squares, the number line is your best tool. The steps are: find the closest perfect squares. Those will be the integers that the decimal answer will be in between. And to estimate the decimal value, look at which integer is closer.